All right. Okay. So, Brock, tell me what you know about fractions.
So there can be odd denominators
Okay.
and mix numbers with them, and you can't add them or subtract them with odd denominators.
Okay. But what is a fraction?
It's parts of a whole.
Parts of a whole. Okay. So when you see fraction problems, like Mr. Smith gives you fraction problems, how do you go about solving them?
Well, how? What?
Like, do you use tools, or do you draw pictures, or you just write numbers?
We usually write numbers.
Okay.
On.
Have you used tools to work with fractions?
No.
No? Okay. We're going to use some tools today. All right. And one more question before I show you the tools. How, you're going to, is it a party tonight or just a sleepover?
Just a birthday party.
It is a birthday party. Okay. Yeah. So I'm guessing you're going to have cake maybe?
I don't know.
You don't know, maybe. Do you think you'd be using fractions okay, how would you be using fractions?
Like when you slice pieces of cake, if there's 12 holes and someone takes 2 pieces, it's 12. It's 2 12s.
Okay, so if the cake is the whole, and then if there's 12 kids, you'll cut it into 12 pieces.
Yeah.
No, so you use fractions every day, whether you realize it or not, right?
Mm-hmm.
Okay, so I'm going to show you 2 things. One, I know you've seen before. You've seen these before, right?
Mm-hmm.
Okay, so these are just plain old fraction bars. All right, so think about fraction bars. There's only one size hole, right?
Mm-hmm.
And then all the other pieces fit below it to this hole. Okay. Now, did your mom show you the Cuisinart rods? No. Okay, I'm going to show you these. Please see this one. And this is something you can use today if you want. All right, these are called Cuisinart rods. I use them with fractions or other things, but I like them because they don't have numbers on it. So any of these can be the whole. So say that's my whole. And I can use, let's see, I can use these yellows for what size fraction? This would be my 1/2. Or I could take the yellow and then I can use a different color. I think that's too big. What color? Maybe red? Okay. No. Can you help me play around with these? But you can use any of these as the whole and then use the smaller pieces to find a fraction of it. Yeah. So I think it's a lot more diverse than these. So you want to play with them for a minute and kind of play around with them. And then I'm going to give you some problems to solve. Next, I'm going to get my phone, if you don't mind. I might take pictures of what you do, the work you do. Isn't that cool? So you know what you just made?
Fraction.
You did make a fraction. You made, what fraction is that?
3 1/3 for each of them.
Okay, well, so something about fractions is, for it to be considered a fraction, it has to have equal parts. So if this is your whole, for this to be 1/3 of it, all 3 of these would have to be purple because they have to be equal. So if you want to make 1/3, we need to find a different size that would work with that. Okay, that was half, but I want to show you what's cool. So put your purples back and your red. So, remember earlier you said about adding fractions? They have to have a common denominator. All right. So, this is kind of cool because you want to make a whole. So, if this was the fraction, you'd have to find the common denominator in order to add those together to make this.
So I would have to make half of that.
Okay.
And if you take those two, you could just keep adding red ones
There you go.
to make fours.
Yeah. Awesome. So you tell me, what did you here? Put these here, like as a visual. All right. So, what addition problem did you make with the purples? And that one ran here. Okay. All right. You want some help? Okay. So you found a common denominator. What is the common denominator? You cut this into what?
1/5.
Into fifths. So that's the common denominator. So these purples, each purple stands for how many fifths?
2.
Okay, so you have 2/5 plus
4/5.
2/5, which is 4/5, plus 1/5 equals
5/5.
5/5 or 1 whole. Now these two purples, let's see. These two purples together would be,
1/2.
well, not with, well, if it was just the reds, it would be, you're right, it'd be 4/4 and 1/2. But these are really neat to play with, and I gave your mom a set if you want to just kind of play with that. So I'm going to do is I'm going to give you a question, and you can use these to help you solve it, or you can draw pictures, but it's not a test. You're not great on it. Like I said, I'm great. So we just want to see what your thinking is. And I have 4 all together, but we might just do a couple today, and then I'll do a couple next week, okay? All right, so there's a pencil. All right, so there are 12 children sharing 9 candy bars equally. How much candy bar will each child get? So you have 12 little pieces there? Okay. And what are you looking to find there?
The equal amount, like the biggest amount of things so they can be equal, like each.
So the red, is that representing the children or the candy bars?
The children.
Children, okay.
But there's only 4 of these.
Mm-hmm.
So each get 1/4.
Each would get 1/4. Okay. So if there's 12 kids and they each got 1/4, what's another way you could show that? How many 1/4 would you have?
3.
3 1/4?
Yeah.
Okay. So if we said 1/4 plus 1/4 plus 1/4, how much?
3/4.
It's 3/4. So is each child getting 3/4 or are they each getting 1/4?
3/4.
3/4. Okay, good. I like that. Now, how did you figure that out?
If you put 12 children, you try to get wholes and see what are like equal.
Okay.
for them. And since one whole of it is 3,
Oh,
each get 3/4.
3/4. Okay. Can I take a picture of that? Do you mind?
Do you want me to like put it
Oh,
together?
no, that's perfect the way it is. Okay, awesome. All right. So, what do these parts and this tell us about the numerator and the denominator of your answer? You got 3/4. So, what are these parts telling you about the difference of the numerator and the denominator?
Well, the denominator would be 12
Okay.
because there's 12 children,
Okay.
and each get 3/4.
Okay.
So it would be 3/12.
Okay. So, you had 3/4. Okay. And that's how many each child get. But you said there were 12 kids, 12 children. So, would that be your numerator or denominator?
Numerator.
Your numerator? Okay. And what would the candy bars be then? If that's your numerator, then that would be your
Denominator.
denominator.
And that's a mixed number.
And that's a mixed number. Is that going to give you 3/4? No. What about that? Will that give you 3/4?
Mm-hmm.
Have you learned about simplifying fractions yet?
Mm-hmm.
Okay. So if we were to simplify this, if you were to simplify that, what would you get? Do you remember how to simplify? Yeah. Okay. Okay. Let's stop for a second. How'd you get 36 for both of these?
The lowest denominator that each can
Is what?
multiply. 36 for each.
Okay. So you're trying to find. All right. So I'm not supposed to be doing this as part of my assignment, but I'm going to give you a little lesson here. It's like a reminder. So if you want to simplify, you need to find common factors. And what's a factor? Do you remember?
Like everything that can multiply.
Good. Everything that
these
good. So how can we get 9? What can we multiply to get 9?
3 times 1 times 9.
1 times 9. What else?
3 times 3.
3 times 3. That's about it, right? Until we get into decimals. All right, what about 12? What can we multiply to get 12? We know 1 times 12. What else?
3 times 4.
3 times 4. Okay. So you see something the same?
Yeah.
Okay. Yeah. So now you can either multiply to get a bigger equivalent fraction, or you can divide. All right. So go ahead and divide 9 and 12 by 3 and see what you get. Okay. So what's your equivalent fraction of 9/12?
3/4.
So without even knowing that you did it, you knew that each child's going to get 3/4. Without even knowing that, you could say 9 candy bars with 12 children would give you 3/4. That's pretty cool, isn't it?
Mm-hmm.
Awesome. Okay. All right. So I'm going to give you one more question, and then we'll take a break. All right. Okay. It's a similar question. There are 6 candy bars for 8 children to share. If each child got the same amount, how much would each child get?
each get 2 parts of
And you don't have to use those if you want to draw pictures too. That's fine. So think about, what are you sharing? Are you sharing children or are you sharing candy bars?
candy bars.
Candy bars. So what are you going to break apart, the candy bars or the children?
Candy bars.
Okay, so how many candy bars are there that you're going to break apart?
6.
6. So why don't you try going from 6 instead of the children? Try it with the candy bars and see if you can break those apart easier.
There's 4 left over. So
Okay. Okay.
You would divide each of them so like that. And so you can get 4, like one, like 4 children get one, 4 children get another. So it keeps like going like that.
Okay.
So you only need 2 candy bars to feed all the children.
Okay, so we only have to use 2, but we have 6 of them. So go show me on this candy. So you said 2 candy bars to feed 4 kids.
No,
What
one
is it?
candy bar
Or to
is
feed 4.
kids.
Oh,
Yeah,
2 candy bars is 8 kids.
Yeah.
All right. So
Each get 3 parts of the candy bars.
okay, so each child would get 3 parts if you use all of them?
Yeah.
Awesome. So write that as a fraction for me.
Like as a.
So which is the 3 going to be, the numerator or the denominator? What did you break it up into? How many parts?
4 parts.
4 parts. So that represents the what?
The
Denominator. So put that for your denominator. And you said each child gets 3 of that. So write 3 above it. Okay, so each child gets how much of a candy bar? 3/4.
And if you multiply by 2, it gets 6/8.
Look at that. Awesome. Okay. I'm not going to take a picture of this because I have this. All right. Let's see. If I'm going to save this question. Let's see. Well, you know what? I do have a question. Why is it important, like you drew pictures and you drew awesome pictures, why do we label them, the different parts of a fraction? Like you said this was 3/4, but what if, and then you said it was also equal to 6/8. So why do we label them different ways?
Because if like sometimes you have to, you can't simplify.
Okay.
For every question.
Okay, yeah, you're right. Sometimes you can't simplify. Awesome.
Or sometimes you have to multiply for it to get higher denominators.
Okay. All right. And then can you compare those? Like when you said this was also 6/8. If you were to compare it, like
it would be equal.
It would be equal. Good job. All right. Well, I'm going to pause this and we're going to stop right now. Let's see. Oh, where'd it go? Stop.